start some new material. Here we forge forward, and this material is, you are very familiar with pretty much all the material we'll be working on today. All right, or you should be anyway. I'd be stunned if you're not. We're going to talk about statistics and applying them a little bit. And first, we'll start with talking about the distribution of a variable. The distribution of a variable or data set describes the values taken on by the variable and the frequency or the relative frequency of these values. All right. In other words, how are they distributed? Now, we did this a while back when we did that purple and white chart with the 50 TVs and stuff. So if you remember, we said that there were, one home had no TVs, 16 homes had one TV, 14 homes had two TVs, and so on. So that is a measure of distribution, and it's with that we're going to start defining a few terms. And the first terms we're going to define are measures of central tendency. In other words, the center of the distribution of data. And they are, from your youth, mean, median, and mode. Yes, yes, yes. The mean is the sum divided by how many values there are. The median is the one in the middle, but they have to be in order. And if there's two of them, then you in the middle, then you take the average of those two. So for instance, if there's 7 values, there's going to be one in the middle. It'll be the fourth one. We'll do some more concrete examples in a bit. But if there are 8 values, there's not going to be one in the middle. There's a set of 4 and a set of 4. And the middle will actually be the average of the fourth and the fifth term. We'll give you some concrete examples, but that's how you find the median. And the mode is the most popular or the most common value or possibly group of values in a distribution. So to give you an example, here is a sorted list. So you start out with the numbers 6.72, 3.46, 3.6, 6.44, and 26.70. Your job, very first thing you're going to do, because we're going to find mean, median, and mode, is you got to reorder the list so that it goes from lowest to highest. Okay? Now, as far as the median goes, because this is an odd number of data in the set, 6.44 is the exact middle. There's 2 below, there's 2 above, 6.44 sits in the exact middle. That's the median, 6.44. As opposed to this guy, here's the 4 values, 6.72, 3.46, 3.60, 6.44. I reorder them from lowest to highest. 3.46, 3.60, 6.44, and 6.72. But because there's an even number of them, I'm going to find the 2 in the middle and take the average of them. So I add them up and I divide by 2. That's how I get an average of 2 numbers. So in that case, the median is 5.02. Notice it's not on the list. But when there's an even number of terms, we just take the average of the 2 in the middle. So those are some median examples. If I wanted to find the mean, I would just add them up. I'd do 3.46 plus 3.60 plus 6.44 plus 6.72, add them up and divide by how many? 4. That's right, because there's 4 terms. Okay, what about mode examples? Here's 3 examples of mode. In A, what's the mode? The most popular or the most common? It's 5. Clearly, there's lots of 5s. In B, what's the mode? Well, there's actually 2 of them. It could be, it's what we call bimodal, and the 2 modes are 2 and 6. You know how bi always means 2, so 2 modes, bimodal. And then what about C? Well, in C, there is no mode, no number of repeats. So it's possible to have 1 mode. It's possible to have more than 1 mode. It's possible to have no modes, depending on the data set that they give you. Again, for the mean, I really don't think that we need to go too crazy on the mean, but you just add up how many there are and divide by how many terms there were. Okay? So add up all the scores, divide by how many there are. Shapes and distributions. Now, the first one is pretty close to what we call normal curves. Not exactly, but pretty close. And we would say that they are unimodal. They have a single peak. Okay, there's one mode if I graph that data out. The mode is the most popular or the highest point because that's where there's more there than any place else. The second one is what we call bimodal because there's two peaks. Anytime we find peaks, we're looking at more than one peak, two peaks. It's a bimodal distribution. Single peak is unimodal. And that makes sense, right? Uni means single and bi means two. So, shapes of distributions. Graphs give you a picture of how the data is distributed. Three characteristics of the frequency distribution are important to consider. First, how many peaks? Is it unimodal, bimodal? Could be trimodal. Is there symmetry? And variation, how spread out is the distribution? That's really important to remember. So, we start with this data and let's make sure that we come up with the same solutions, all of us. First, they give you the data and they don't order it. 587, 967, 763. And because median is dependent upon order, and because ordering it allows you to not make a mistake with mode, we definitely prefer, as long as there's not too many numbers, to order them. So taking the same numbers but rearranging the order, I get 3, 5, 6, 6, 7, 7, 7, 8, 9. One of the things that jumps out at me instantly right away is that 7 is the mode, right? Because we put them in order. Now, what about the one in the middle? Well, that's also going to be 7. Here it is, because there's a group of 4 below and a group of 4 above. Notice there's an odd number of terms. There's a total of 9 terms. So with 9 terms, it'll be 4 below, 4 above. Okay? The way you figure out if there's let's say there were 21 terms. The 11th term would be the median. You just do 21 divided by 2, that's 10. And then since there's a little bit more, you have to go to the 11th term. Next up is the mean. So to do the mean, we just add them up and divide by how many there are. In this case, 9. So 3 and 5 is 8. 8 and 6 is 14, and 6 is 20. And then these 3 7s are 21, so I'm up to 41. And then I'm up to 49, and then I'm up to 58. So I do 58 divided by 9, and when I do that, I get, rounded to the nearest tenth, 6.4. Okay? So that's a little calculation and the kind of things that, honestly, we did in middle school, so I don't think it's particularly difficult for you. Okay. Now, outliers are a little different. Outliers you start getting introduced to more when you get older and into high school and reintroduced now. An outlier is a data value that's much higher or much lower than almost all the other data. Now, to be clear, I also teach a course in statistics, and there is a statistical definition of an outlier. We're not going to go with that. We're just going to look at the number and say, hey, wait a minute, is this really far away from where all the other data is? Is it a whole lot lower, or is it a whole lot higher? For instance, if you had the data that said 10, 11, 12, 13, 14, 15, and then you also had the data 0 and 16, well, 16 is not an outlier, it's really close, but the 0 is. The 0 is really far away. And if I had that same data, 10, 11, 12, 13, 14, 15, 16, 193, 193 is an outlier because it's way higher than the other data. So, how does an outlier affect things? Well, here's the same data we had before. 3, 5, 6, 6, 7, 7, 7, 8, 9. You remember that the mode was 7 and the median was 7, and those are staying the same. But recall that the mean was 8.4. I'm sorry, was 6.4. Now we put a 25 in there, and that changes so much with respect to the mean because you're going to add 25, and that's so much bigger than any other number. So the mean takes a jump from 6.4 all the way up to 8.3. And by the way, the median stays at 7 because now we have 10 terms. So there's 2 groups of 5, the 5 down here and the 5 up here. And that means there's 2 7s in the middle. So the average of 7 and 7 is 7. Another outlier to affect here. This time we put in a negative 25. And look at how that pulls the mean down. Okay, because it's smaller, this time you'll notice that the mean, that the middle, there's still 10 terms, right? Cut it in half, that would be 5. So it'll be because it's an even number between the fifth and sixth term, and the fifth term is 6 and the sixth term is 7. So the average or the middle of 6 and 7 is 6.5. Okay, so symmetric and skewed distributions. The word symmetric means it looks the same on both sides. You are symmetric. If you took a line and you drew it right down the middle of your body vertically, then you would match. You have a leg and a leg down low. You have a foot down low. If you go up higher, you have an arm and an arm. You have an eye and an eye either side of this line. That shows that you are symmetric. But sometimes the data kind of swells to the right, and sometimes the data kind of swells to the left as the two graphs underneath it go. Okay, they're called left skewed and right skewed. Now you might say, but wait a minute, that hump is on the right. Why do they call it left skewed? And that's because the data, the outliers that are all low values are going to make the data seem lower than it really is. So that's why we say it's skewed to the left. To skew means it's distorted to the left because of those outliers in the low values. That's called a tail. This region right down here, it's called a tail. And it kind of pulls the mean down that way. So we don't want that. Now, right skewed means the opposite. Even though the mound or the hump is on the left, the skewing, it's called right skewed because there's some outliers out there way, way, way out on the right that kind of distort the mean. See, if it's symmetric, the mean, the median, and the mode are right in the middle. But when you're left skewed, it slides the mean, the median, and the mode to the left. That's why we call it left skewed. With right skewed, it slides them to the right. Next up, variation. Variation is not so much about central tendency, which mean, median, and mode are, but it's how much the data spread out from the center of a distribution. So low variation means all of the data is packed in a really small range or area of the graph. Moderate means it kind of looks normal, and high variation means, whoa, it's really, really, really spread out, okay? From left to right, they're increasing in their variation, and variation describes how widely the data values are spread out around the center of a distribution. Variation is a measure of how much the data values are spread out. That's what variation is. It varies. Vary means changes. So here's another one. Low variation, moderate variation, high variation. From left to right, they have increasing variation, right? Low, moderate, and then way high variation. Variation describes how widely the data values are spread out. So those two sets really were designed to get you to recognize how variable data can be. So here we have basketball teams. We have team 1 and we have team 2. In both cases, the mean is 75 inches. So if you were to add them up and divide by 5, in both cases they come out to have a mean of 5. But if you just look at the numbers, you can see that team 1, the data is pretty tightly condensed. And in team 2, they're pretty spread out. And we'll come back to that in just a minute. Now, the measures of variation are range, quartiles, and standard deviation. Those are the 3 that we're going to go over. The range of data is the difference between the highest and the lowest. So this is, again, data. Range is something done in middle school. Range is simply highest minus lowest. For team 1, the range, the highest score is 78, subtract the lowest score 72, and you get 6. For team 2, the highest score is 84, minus 67, and you get 17. So just by the standard of range, the measure of range, we can say, look, team 2 has a greater variance than team 1. But we can be a little bit more specific about that variance, and we can talk about quartiles. The quartiles of data of a data set divides the set into 4 equal portions. 4 quarter quartiles, the first, second, third, and fourth quarters. Kind of like a football game. Now, in the middle of the second quarter, the second quartile is the overall median of the second quartile. The lower first quartile is from the first quartile, and then the third quartile goes from in the third block of data, and the fourth, the upper quartile is also called the third quartile. That's from the third block of data, and the fourth is from the fourth set of data. So check this out. Ready? A 5-number summary. You're going to get a minimum. You're going to get a first quartile, a quartile from the second quartile, which is also known as the mean. As the median, and then the third quartile, and then the maximum. So here's how you find quartiles. Ready? Come on. Here's a basketball team, and here's the heights. This is the first group. You have 72, 73, 76, 76, and 78. So, what's the first quartile? It's the median of the lower group. What's the second quartile? It's the median. What's the third quartile? It's the median of the upper quartile, or the upper group. So the minimum is 72. That's the lowest score. The first quartile is 72.5. The median is 76, or the second quartile. We typically call it the median. The third quartile is 77, and the last quartile, or the maximum I should say, is 78. Now the really cool thing is that you can do this on your graphing calculator. You can put the data into a graphing calculator, and you can simply say stat, then you go to edit, and when you go to stat edit, clear out the lists, and then go to list 1 and enter the data. 72, enter. 73, enter. 76, enter. 76, enter. 78, enter. Then you go to stat, and then you go to calc, because you're going to calculate some things. And what you're going to calculate is one variable, stats. So you hit enter, and of course it's list 1. And you'll notice that nothing about quartile comes up right away. But if you keep going down, it'll tell you that the minimum is 72. The first quartile is 72.5. The median is 76. The third quartile is 77, and the maximum is 78. So you can do this on the graphing calculator. Again, you go to stat edit, put all of the data in list 1, then you go to stat calc, you do one variable stats, you hit enter and keep scrolling down, and then you'll see minimum, quartile 1, median, quartile 3, and maximum. Now we do it with the second group of numbers. 67 and 72, 76 is your median, it's the middle. The median divides into the groups, okay? And then 76 and 84. So your minimum will be the lowest score, which is 67. Your first quartile is the average of this lower group, 69.5. We said the median was the one in the middle, it was 76. The third quartile, or the upper quartile, is the average of this upper group, 76 and 84. I say average, I should have said median. It's the median of that upper group. I'm a little flippant with my language there, and I shouldn't be. Quartiles are always medians. So it's the median of the lower half, the median overall, and the median of the upper half, which is 80. The maximum value is 84. So the 5-number summary is minimum 65, 67, first quartile or lower quartile 69.5, median or second quartile, which again most people don't say second quartile, 76, third quartile or upper quartile, those terms are interchangeable, 80, and maximum 84. Last sheet for you to do today. Find the minimum, first quartile, median, third quartile, and maximum. Go ahead. Assume you did your stop and start. If not, do it now. So, the first thing I need to do is find the median, and the minimum, and the maximum. So the median is the guy in the middle, and there it is, it's 17. So that allows me to know the minimum, the median, and the maximum. And consider they're looking to summarize this with 5 numbers. I've already gotten 3 of them. Minimum is the smallest one. That's easy. Maximum's the highest one. That's just as easy. And the median is the one in the middle, and you already knew that. Notice that the median divides this into two blocks. A block of 3 below the median and a block of 3 above the median. You now need to find the median of the block below and the median of the block above. The median of the block below is 11. The median of the block above is 20. It's as if once you do this, the only 3 numbers in the world that you consider are 8, 11, and 12, and just find the median, the guy in the middle. It's 11, not hard. Then you look at the numbers above. Don't consider anybody else. What's the one in the middle? It's the 20, so that's the median above. And that would be what we call the first quartile for 11, or the lower quartile. And the 20 would be the third quartile, or the upper quartile. Now that I know these numbers, I just plug them in. All right. Enjoy, guys. Have fun.